So we're recording things now. Okay. And Linda, before you leave, I'd maybe like to do a poll about how the students are, but I don't, well, in fact, maybe we'll do that earlier or along the way. And my, that's not going to work. I'm forgetting about my video. There's an issue that I have and I have to fix that. Okay. So anyway, it is 9:15. This is the VCM. And Linda will be very surprised to know that not only did I post it to this syllabus tab, but I put it in the net syllabus tab too. And so, you know, that probably will never happen again, but it did tonight. Okay, so let's go then. I advanced the slide. So I'm going to talk for a while, just say some things that are on my mind and make some talking points here. And then your comments are always welcome, but there's a slot down there for your comments and questions. Student Q&A before we leave this. And Linda, what we'll do at the end of the student Q&A, we'll do that little poll. That's probably a good time to do that little poll. So we can think about that. Yeah, it's just how are they? Okay, so I'm going to start talking, and Linda will get to talk to say whatever she wants to before the student Q&A. So anyway, here we go. This is my script. Okay, so we're doing just fine covering material. In my own head, the way I think about things is I want to do statistics before midterm, and I want to do physics after midterm, and I think we're on track to do that. So that's, you know, that's a good thing. Now, from the statistics book, and I know some of you have the book, some of you don't, but all of you can go in and look at these books in the Learning Commons. They have multiple copies of them, and you know, that's fine and that's free and everything else. We have covered from the Sullivan book chapters 1 through 4 and pretty much 7. Now I may say a few more things about 7, but you know, we've got I think we have 5 chapters under our belt, so that's good. And we're going to be beginning the chapter that's called chapter 5 tonight. And we're going to start with a discussion just because I think this is a good way to jump into it. We're going to start with a discussion of simulation. And so that's actually, it's not chapter, it's section, but it's 5.6. But, you know, I think we'll cover that off tonight, and we'll cover some more things probably. And also, the next LSA is going to be announced in here, and I don't know what number it is, and I don't know when it will be due, but you guys will get to see it during the discussion tonight. And very soon, there will be more videos that I'm going to point at to you to work, because we really want to, and we're getting to the point where we're concerning ourselves with samples. And so we're going to be talking about samples, and eventually we're going to be doing confidence intervals based on samples, and so on and so forth. So that's some good stuff. So more videos will be coming soon. I can't promise that's going to happen tonight because I never know what will happen. I do plan to have office hours tonight, I know that. Okay, and then we have announced, and I'm, you know, keeping with this, that October the 12th will be the midterm launch date. Now, it will be launched and announced in the in the testing center, the COD testing center. That is 2A. Wow, I'm not sure. I'm going to guess 2A07. It's somewhere in that corridor. It might be not room 2A07, but you know, you can look it up. You'll find it if you're walking in that hall in the big building. And if you are in need of accommodations, you want to be talking to me about those. And there can be different kinds of accommodations. Now, I don't think anyone needs to tell me, oh, I need extra time, because you can take as much time as you want to take that. So, you know, that's okay. But if you need other kinds of accommodations, for example, I told you before, but it is true, I have a student in Saudi Arabia right now, and I have and over the summer I had a student who was in Taiwan, and so those are like way different time zones, and those people are not going to fly in to go to the COD testing center. That would be a real expensive trip on any airline. So anyway, that's what's happening. And to tell you the truth, I think that's all I have to say here. Okay, so Linda, I guess I'm turning over to you. Anything you want to remind the students of, or tell me I should talk about, or whatever. It's your, you have the ball.
I think I'm pretty much good. The GSG was a little bit slower tonight, so just a reminder, you guys can come and go as you wish. You don't have to stay the entire hour. If you just want to pop in and ask a quick question, then you absolutely can.
Now, I saw a couple of our students in the, I am one of the stalwart people from the Learning Commons got an excellent job offer, and so they're off doing that. And Cheryl needs a couple of time slots filled, so I stepped up to do that. And actually, I'm having a blast because just working with students, I don't know how Linda feels about this, but working with students is, it's all the fun of a class, but it's none of the unfun parts of a class. So actually, I'm having a blast doing that pinch hitting. Okay, so Linda says she's done. Linda's comments are always welcome, though, so she can say whatever she wants, whenever she wants. But now we'll go to student Q&A, and I'll count till 10 Mississippi to see if anybody has anything they want to bring up. Looks like Nicole Barnes has raised her hand, so I'm calling on her. And as you know, I always restart the count after there's, something that happens here. Go ahead, Nicole.
Hi, Mr. Bradley. I was calling. I don't know if you received any of my texts, but I tried to get into your office hours every day last week. I think Wednesday and Friday, and my Zoom just kept on going around and around. I didn't know if you had trouble on your end, but for some reason I can't get back into your office hours for Zoom at night.
Well, okay. Now I'm just reacting to your, the symptom that you're describing.
Mm-hmm.
Um, and by the way, there are times when I have technical problems, just like the rest of you,
Mm-hmm.
and usually. And I'll tell you, and I think one night I had it, but I only remember having it one night. But what happened was that I had a power outage, and I got home, and then I turned my computer on, and I had to reboot everything, and it took it seemed like days.
Oh.
But I did get into, no, it wasn't days. But it seemed like days. It was like 20 minutes or something before I could get the whole thing rebooted. But I was in there. But Nicole, I'm going to tell you, and again, I'm not arguing with you or anything else, but what happens in my Zoom, the
Mm-hmm.
way I have it configured, is if somebody tries to get in, and they have to reach a certain level of success. But
Mm-hmm.
like on that night when I was 20 minutes late because everything got screwed up,
Mm-hmm.
um, I went into my email, and you see my email says, "Oh," and what we have no Suzie Smiths in this class, but my email will say, "Hey, Suzie Smith went to your Zoom at
Mm-hmm.
like maybe 8:59 or something." So anytime I see something like that, and if Suzie Smith wasn't there later, I reach out to her. But I talked to everybody who showed up that way. So, and Nicole, I'm not insisting on this. I'm just saying,
Mm-hmm.
making my diagnosis is I think it was something on your end.
Okay. Yeah, I kind of.
Okay. Now,
Yeah.
and now we want to figure out a way to fix that, and we're not going to fix that in this session tonight. But I
Right.
think there's something on your end, and we need to, try to figure that out. And maybe what I will do, no, in fact, I guess I will promise to do this, but I have to remember to do it. Okay, so I will plan on, Nicole, if it's all right, I
Mm-hmm.
will plan on, wow, let me see. I actually can look up your phone number on in College of DuPage databases, okay? So I'll
Okay.
look that up, and I will try to call you, and somebody's trying to call me now too. Let me
Okay.
see who that might be. This is my brother. He is my best friend. I just want to check that everything's all right. So hold on for just a minute.
Okay.
Hey, Grant. Okay, well, okay, but I will reach out to you soon, and I am teaching class right now, so that's why we can't talk. All right, bye-bye. My brother truly is my best friend. He reminds me of my father so much. He is kind of the spitting image of my father, and in every way, physically and emotionally and everything else. It's almost like I'm talking to my father. Okay, Nicole, I'm going to try to call you
Okay.
when this class ends. It might be 7:30 or something, but I'll try to call you then. And so if my phone number comes up, just answer it, because I do care about you, but we're not going to solve anything here about that. Okay.
Thank you so much.
All
I
right.
appreciate it.
So I will call Nicole. Okay, I'm starting the count again. Okay, I hit 10. Your questions are always welcome, but we're just going to go ahead. And Linda, you and 7 are good to work at least until you have to leave, right?
Yes, we're good. Do you want me
Okay,
to do that
great.
poll real quick before we get started?
Oh, yeah, and of course I forgot that. Why don't you do the poll? Okay, so, and please respond to this, because we don't have, we're not taking grades or anything like that. Okay, that's probably good enough. I'm just reacting to what I see. Um, looks like 12 of the 23, that's over half, were saying that they're either on top of things or they're okay, and that's good. I want everybody to be okay, of course. And some of those who say you need help, hope you know where you can get help. You can go to Linda's GSGs. You can come to my office hours. You can come to the Learning Commons and either visit Linda in drop-in tutoring, or talk to some of Cheryl Martin's team in the math assistance area. And in fact, some people came and talked to me today. That was when I was pinch hitting for this other person, and I had so much fun. I'm probably going to do it again whenever their hours are up. So there's a lot of places to get help. So get help, and there's still time, because the midterm's not, well, it's less than a month away though. But anyway, that's there. Okay, so Linda, thank you for the poll, and we'll just jump in, okay? So I'm advancing the slide then, and we are going to talk about a little bit about, I'm going to call it simulation. So this is really in chapter 5.6 if you're following in your book or reading in the book in the Learning Commons or something. But we'll talk about a random process, and that represents scenarios where the outcome of a particular trial of an experiment is unknown, but the proportion or relative frequency a particular outcome is observed approaches a specific value as the number of trials increases. Okay. Now, I don't know, I think I like a lot of this definition. I'm not sure that it has to approach a steady state, because if this is chaos theory, it doesn't approach a steady state. So I don't know if I would have written that definition the same way, but that's kind of okay. Now, there is a thing called the law of large numbers, and this is really what simulation is based on. As the number of repetitions of a probability experiment increases, the proportion with which a certain outcome is observed gets closer to the probability of the outcome. Okay, so just keep that in mind. And Linda said that she and 7 were ready to work, and so I'm going to ask them to generate a whole bunch of Excel things in just a little bit, because it's the law of large numbers, so we're going to do a bunch of these. Now, what I do if we were in class, I decided this would not work on a VCM Zoom link, but if we were in class, you all would have the workstations in front of you, and I would maybe ask Linda just to do 25 of these, and I'd ask everybody else to do 25, but then we have 23 people in class, so we'd end up with 500 trials, which is a large enough number to, make this this thing kick in. But anyway, we'll continue going. But this is an important thing, and this is really what simulation is based on. You do a large repetition of these things, and you say, oh, we know pretty much what's the probability of the outcome. Okay, so so I highlighted this. Now, simulation, for the most part, I'm going to consider this to be something using a computer. Now, simulations can be tactile. Like, for example, I could give you a spinner, and in some of our videos, they show a spinner that they would take people and they'd spin it, and it would be either placebo or they would be part of the controlled group, and all of that, and that's how they could sort people. So that meant tactile. If you're spinning a spinner. But we're going to be talking about random number generators from a statistical spreadsheet. So that's what we're going to be doing tonight as we go through this, okay? And so we are using a computer. And the reasons you do simulations is sometimes it's too expensive or cumbersome to do something, and you can get a lot of mileage out of this. And in fact, there are many ways that I've been blessed, but one of the ways I was blessed was I studied with a great person in simulation, and his name was Dr. Alan Prisker at Purdue, and I have stories about him, and I've told the stories in class, and I think the stories are really funny, but some students didn't get it at all, and other students didn't think it was funny, and so on and so forth. So I'm not going to tell you those stories because this is a VCM. But in doing these simulations, what we do is we randomly generate outcomes to represent results from a random event. And we are going to be doing this in just a little bit. Okay, so here we go then. And we're going to play the GOAT game. And Linda, I'm going to ask you to play this game instead of other people. But this is an example of what we're going to do as simulation. And by the way, it occurs to me that GOAT is one of many words that mean something different. And Linda, I'm sure knows, but when a young person says something is sick, that maybe means something is ill. That's what it used to mean when I did, but also that can mean that something is really cool. Now, my sense is it's spelled differently. S-I-C-K is what you use to say ill. And if you're saying something, that song is really sick or something like that, I think you use S-I-C, but I don't even know. But if somebody's talking, you can't tell the difference, and that confuses me. The reason I brought that up is goat is another thing. For me, goat is a farm animal. And it's a species, out there and things like that. And you can eat goat meat, and goat milk is considered good. And in fact, they make goat cheese from goat milk. And so, and goats also do a good job of eating weeds and things like that. So in a farming community, people will talk about that a great deal. But now, more often, when I see the word goat, it is in all capitals, and it's an acronym, and it means greatest of all time. And so, these words keep changing. Now, Linda, and even though I think highly of Linda, and who knows, Linda might end up being a greatest of all time in her chosen field and stuff like that. Linda, we're talking about the critters goat here, okay? So here we go, and Linda is our contestant. So I'm going to the next slide, then I will advance the slide. And here we are. Now, this is going to be a computer experiment eventually. Linda's going to do that. And we're going to play a game called...
Layla has a question.
Okay, Layla, okay. Layla, you lowered your hand.
I can't see the screen. It's not showing.
Can everybody else see it okay?
Yes.
Okay, Layla, you're not going to like my advice, but my advice would be to log out and log back in.
Okay, I'll try that.
Yeah, okay. And I'm sorry it doesn't work. Technology is technology. Okay,
No,
so
it's
I'm down
probably
here.
just me because I'm in a different
Okay.
country. I'll try it.
Okay, hey, and by the way, Layla, if you're in you still there, I hope?
Yeah, I'm here.
Okay, if you're in a different country, you are probably one of those people who want to send me emails about accommodations. And again, you know, the country might be.
I sent
I,
you a
it,
lot of emails. I was gonna talk to you about that because I don't know if you received any of my homeworks or any of my LSAs or any of
well,
my things.
okay. Let me let put the ball in my court. So in addition to calling Nicole, I'm getting a long list of things to do, but that's okay. So in addition to calling Nicole, I'm going to look through my emails and look for you. Okay?
Okay, thank you.
So don't worry. But go, and I'm going to say try to log out and log back in.
Okay, I'll
And
try to refresh it.
if that doesn't work, if none of those things work, just open up the slides in Blackboard and follow on as best you can, and then you can watch the video because there will be a video of this
Okay.
because we are recording this. Okay, now this is called the Monty Hall game because once upon a time there was and this they still show this on the Game Network. They show reruns of Monty Hall doing this. And it's called Let's Make a Deal is the name of this. Now the show still exists, and there's a new guy that does this, and he's very funny. He's one of Drew Carey's friends, and I don't remember his name off the top of my head, and it really doesn't matter. But this is a game, okay? And now here's how the game works. And so, Linda, I'm going to click now. Well, in fact, Linda, I guess I'm going to ask you because I'm not 100% sure. So and in fact, Linda, I'm going to talk to you. If you click, well, I'm going to try to click it. If I click there, that should go to a website, yes?
I know it will on the PowerPoint. I'm not sure if it will through Collaborate.
Okay, but Linda,
It
you're
looks
out there.
like it does, though.
But you
Yeah.
can see what happens, okay? So if it doesn't work, tell me and we'll do something else.
Nope, looks like it's working.
Wow, okay, so I clicked on it and here we are. Now, here is the way the game works. Now later on, Linda and Seven are going to go through, and Seven's name is not on any of these doors, but that's okay. So anyway, this is the way it works. So Linda got picked from the audience because she was wearing an outrageous outfit and was jumping up and down and acting very excited. But anyway, we picked Linda for this, and so she is here. And so I'm going to say, okay, I'm pretending I'm Monty Hall. And so I say, okay, Linda, you get to pick one of these doors, 1, 2, or 3, and that door will be yours, and you will get whatever prize is behind it if you want. So Linda, which door do you pick? And by the way, Linda will either be a winner or a loser at the end of this.
It looks like people are having trouble seeing the PowerPoint. I'm going to try to... Wait, can you guys not see the PowerPoint or not see the web page?
The web page with the doors that he's talking about.
Gotcha. Okay,
Yeah,
let me
we
share my
can't see.
screen then.
I can see like a screen that has the website, but I can't see anything else.
Yeah, so when you click on the link, this is what it takes you to.
Oh, now I can see what you shared.
So you solved that, Linda, yes?
Yes, we're good. You can keep going.
Okay, so everybody is looking at this now. And what I'm going to do, now they really want to be watching, I guess, our screen. But anyway, Linda, I'm going to let you pick. And again, Linda's either going to win or lose. Now, it doesn't mean she's a loser. It just meant she lost this round of a game. But anyway, Linda, which one are you going to pick?
I'll pick door number 3.
Okay, she picks door number 3. Now, I'm not going to, so anyway, let's do this. Behind one of these doors is a car, which is a good prize. Now, Linda just recently bought the car of her dreams. I don't know if it really was the car of her dreams, but she bought a car. And so maybe she doesn't need a car, but still winning a car would be a good prize for somebody. Now, behind the other 2 doors is a goat. And this really is a goat. And so click on the door that you think the car is behind. Now, Linda said that she thought door 3. So she picks door 3 because she thinks the car is probably there. Now, I'm going to click on this, but watch what happens. Now, I didn't show Linda what was, and nor did Monty Hall show Linda what's behind door number 3. And do pay attention to the way the game works, guys, so you can understand what Linda's going to do with this. So I click on door 3. But I'm not showing
click on door
3.
3, otherwise it's not going to open.
No, they can't see what I did?
No.
Okay, this
I
is a
think
little
you
bit
have the
host.
website open separately from me, so both of us are going through different simulations.
Okay, can you, Linda, show only your screen?
Yeah, that's what I have up.
Okay,
So
so
if you're
should I
looking at
just drop
Collaborate,
out?
then you're just looking at mine. Yeah.
Okay, I don't know if I'm in Collaborate. I have to figure out where the hell I am even. That's not Collaborate. That's not Collaborate. Okay. All right, so Linda, you have 3 doors shut right now?
I have 2 doors shut. I know that door number 2 is a goat.
Okay, and that's the way it works. So I'm doing this blind, Linda, but that's all right. Okay. So, you see, so Linda said, I picked door number 3, and what Monty Hall does, and what I do as the host of the show, is I show her door number 2, and the goat is there. Now, that means since there's a goat there, that means the car is either behind Linda's number 3. I don't know, Linda. Sometimes I think we should rehearse some of these things, but anyway, it probably not. We probably will never do that. Anyway, so maybe Linda was right. Maybe it's behind door 3, or maybe it's behind door 1. So now I give Linda an option, and I say, Linda, you can stick with your door 3. You know, I'll let you have that if you want it, or you can switch to door 1. What do you want to do? Now, here's the question.
I would like to switch.
Okay, so Linda's going to switch. Now, Linda, that means you click on door 1, I guess, to see if you win the car.
I did.
She won the car. Okay, and she won when she switched. But the question that I'm asking, the broad question, and Linda, I'm going to ask you to make up a simulation about this, okay? The broad question is, are you better off sticking or switching? And you see the door could have been behind 1 or 3. So which way are you better off? Okay, so Linda, now let's lose this. And Linda, you're comfortable how to make this simulation, right?
I believe so.
Okay, great. I'm going to let you, roll with your thing. But here's what I want you to do. I want you to do, I'm going to say at least 100 trials. So maybe you do 25 and then you pull it over something. And Linda, one of the things you want to be careful about, and I know you know all this, I'm just talking because this is a mistake that I probably would make. You have to paste actual numbers if you're doing volatile things. And you're going to be doing choose random between 1 and 3 because that's how many doors we got. And I've maybe said more than enough, but those are things you want to do. And I want the students to understand what's going on. And I am going to go away from my thing and see if I'm back. Okay, hey, Linda, I am there. Now I can see the thing. I can see your Excel spreadsheet. So Linda, you should be talking now. And folks, you should be following this because we're going to ask you to do something similar to this sometime soon. So Linda, please be talking.
So what I'm going to do is figure out how often I would win by staying with the same door. So what I'm going to do is put down my pick, and to do that, then I'm just randomly picking between 1 and 3. So that is including 1 and 3, and I'm going to drag that down to row 101. So we have the 100 trials. And then I need to copy this and paste it just as the values. Otherwise, it's going to keep changing every time due to the equation.
And
So
by the
next,
way,
what I'm going to do.
I'm sorry, Linda, and that's really important you understand what Linda just talked about, because I really did have a student once upon a time who didn't understand that in a test. Now, fortunately, that student, I was in the classroom with that student. I am not going to be in the testing center when you're doing this. So you really want to understand what Linda said, because that could come up for you in a, in a high stakes assessment environment. Go ahead, Linda.
Okay. So next I'm going to determine what door was the winning door. So I'm doing the exact same equation, rand between, and then I'm going between 1 and 3 since we have the 3 doors. And then I'm doing the exact same thing where I drag it down and then I'm going to copy and paste it. Okay. So now I have just my values. Now to figure out if I won by staying, then those would match. Otherwise, if I switched, then I would have the different door. So if I won by staying with my original pick, then I can subtract those two, and it should give me 0. So I'm going to drag that down. And then from there, I'm going to count how many zeros I have. So my range is all of these. And my criteria is just that it is 0. So I got 38 zeros. So to figure out what the probability is, then I would do equals that 38 divided by the 100 trials. So this would be a 38% chance of winning. Now that means that I have the complement chance of winning by switching. So I can do 1 minus that probability, and I need my equal sign. And that's going to tell me what the chance is of winning by switching.
Now, I'm going to call on Amber, but after we hear what Amber has to say, or her question, and hopefully address it, Linda, I'm going to ask you to explain to the students why, if they did this, they might not get exactly the same result. But let's hear from Amber first. Amber, what's on your mind?
I wanted the Excel function for the counting. I didn't see the end part. I got count if.
Okay.
So that's a count if function.
Okay.
You're highlighting all of the values in column D, and then you put 0 is the criteria.
Okay, comma and then 0.
Yeah, and then just close the parenthesis.
Thank you.
And that's actually pretty fancy, but Linda knows a lot of things, so that's good. Anything else, Amber, or can I lower your hand? Yeah,
I'm good, thank you.
That's fine, and she is good, and it is good that Amber is good. Yeah, Linda. So now, if Amber did this herself, would she get exactly the same result? And
probably not, because it is a random integer. So every time you guys run this simulation, you're probably going to get slightly different numbers. But what you should know is that the probability of winning by staying is going to be about 1/3, where the chance of winning by switching is going to be about 2/3.
And Linda, would you explain why those end up being dates? Yeah.
Because Excel is terrible. No, it just interprets it as a date instead of the actual number.
And that's a formatting issue, okay? And so Linda had to go and deal with the formats a bit. Okay, so that is good, and Linda, that was a wonderful job. Now I think Layla had her hand up. Now I don't really know if that was a question or just accidentally having her hand up. So Layla,
No,
do
it
you have a
was
question?
accidentally. No, it was accidentally, sorry.
Okay, well, don't be sorry. It's fine. I just wanted to make sure we didn't miss a question. Okay, Linda, that was really good. Okay, so thank you for doing that. And let's go back now. And Linda, I'm just going to let you drive because I got screwed up. Can we go? Or I when I clicked on the thing that didn't work. So go back to the PowerPoint show and let's see where we are.
I gotcha.
Okay, so that was the goat story. And that was this was where the hot link is and stuff like that. Okay, and I'm not really going to be asking you about that, but I am going to be asking you about something else. And in fact, here's what I'm going to be asking you about. Now, very soon, this is going to be the next LSA. And off the top of my head, I can't tell you what the number of the LSA is or anything else. But craps is a dice game, and it's a
I think
popular.
this would be number 5.
Okay, thank you, Linda. And I will, announce it and I'll create a due date and everything else, but I haven't done that yet. Although I did pick this out because I think this is a good problem. Okay. And Linda, I don't know what I'm going to read it and then, I'm eventually going to post it and stuff like that. So craps is a popular casino game in its most basic form. And by the way, we're just playing the most basic form. So the rules are right here. So what happens is if Linda was wanting to play, she would put a bet down and it would be her turn. And she put the bet down and we would, and either she will win or she will lose, just like in the goat game. Okay, but then we give Linda 2 dice and she gets to toss the 2 dice. And these are 6-sided dice. And we're going to talk about dice later in this period too, but they're 2 dice and she throws them. Okay, now here's the rule, and it's pretty simple. If the outcome of the roll, now this is the first roll, if the outcome of the roll is 2, 3, or 12, that is the sum on the top of the 2 die. Die is plural of the 2 die is singular. Okay, if the sum of the 2 die is 2, 3, or 12, the player loses her pass line bet. So if she gets 2, 3, or 12, she loses. If the outcome of her first roll is a 7 or an 11, she wins her pass line bet, which means that she wins right away. Now, if she rolls anything other than a 7 or 11, or a 2, 3, or 12, that will be defined as her point. So you see, she hasn't lost yet. She gets to play. And so now she must roll that number again, whatever she rolled prior to rolling a 7. So she keeps rolling till she got that number or she hits a 7. If she rolls a 7 again, she loses her money. If she rolls that number again, she wins. And so there's a little for example here. If the point is 8, the player must roll an 8 before they roll a 7. Now, the reason I sort of, blocked this out is that Sullivan said, hey, there's a data file out there and, play craps with the data file. I'm wanting you to do a simulation of this. And so what you're going to do is you're going to think about this and maybe think deeply about this. And then what you're going to do is you're going to do some, simulation for this. And that's what I have in the blue. So don't go get his data. You're making up your own data using the technology that Linda started talking about. But I want you to simulate 200 games of craps. And I want you to estimate the probability of winning. And this is going to be an LSA. And I will announce it and things like that soon. but I just decided to do this. Linda, is there anything else you think should be said about this before we go on?
I don't think so. If you guys are having trouble, especially with the simulating, then we can definitely go over that. If you guys forget the equation, then feel free to shoot me an email and I can respond back with it as well.
Amber's out there. Amber, what's on your mind?
So it's the sum of the two dice, so it's like 1 and 1 equals 2?
Yes, exactly.
Okay.
And by the way, I think we're going to talk about dice yet again, and so that
Okay.
will become even clearer to you when we do that. Okay, that's great. And I hope we answered your question. My goal is always to answer questions. Okay, Linda said we were probably good with this, so we'll go on then. Okay, now I'm going to make some, and by the way, here's a picture of a dice. And you can see the 2 is on top, the 3 is there, the 6 is there, and the 3 other faces are having different numbers on them. And this is called, let's see, what is here? Oh, a fair die, and we only use fair die. We don't use die that are loaded or cheating die. A fair die is one in which each outcome is equally likely. We're going to be doing that. And so rolling a 2 is just as likely as rolling a 5. Now you see that's one roll of the die, so getting a 2 is as likely as rolling a 5 when you load it. And you can get funky results if somebody messes with the dice, but we're not cheating like that. But we do have a definition, and Linda's going to in fact do, and Linda, I am being mindful of your time, but I think you can make this fit in just fine. The sample space S, this is a definition. The sample space S of a probability experiment is a collection of all possible outcomes. And we have a definition of an event. So this is the definition of, it's all possible outcomes is the sample space. And Linda's going to show you a sample space. And Amber, this is the dice game that I'm talking about that you can look at, okay? And then we have an event, and this is another definition. And an event is any collections of outcomes from a probability experiment. So Amber, the only reason I'm talking to you is because you asked a question, but an event would be, I roll the dice and I get a 7. That's an event. An event consists of one or more outcomes. We denote events with one outcome, sometimes called simple events, as E. And if we talk about events that are not simple events, we use maybe a capital E. These are going to be sets of outcomes. And so hold on a little bit, but we'll get to that. Now, Linda, I'm going to ask you, and this is not going to surprise you, I'm going to ask you to go to Excel, please.
Okay.
Hey, Linda, are you
And I
doing
think
okay
I've
with
already
art?
done what you think I did.
Okay, great. So go ahead and
Yeah, no, I'm
go
good.
there. Okay, I can't see it though. So here we go. Oh, that's great. And Linda did a
You should in a
wonderful
minute.
thing. She's good. She's very good. But notice one thing, and she'll probably talk about this, but in fact, I'll just say and ask her to explain. Linda, why did you color one blue and the other green?
So this is because we have 2 different dice that we're rolling. So one of them is my green die, the other one is the blue die. So you can see exactly which outcome would cause which numbers to happen.
And Linda, what is the sample space here?
The sample space would be all of the possible outcomes, so that would be everything inside of the chart.
Okay, now Linda, I would like for you to go through here and make a probability table of X and P of X just based on the table.
Okay. So my options for X are going to range from 2 to 12. So first I'm going to list those out. Now for P of X, that's the probability of X. then there are 36 different outcomes. So I can take the number each of these appears and divide it by 36. So for this one, then 2 appears once, so that's 1 out of 36. And this is going to give me dates again. Okay. Next is 3, so that appears twice. And I'm not simplifying the fractions just because it's already going to turn it into a decimal. I have 3 4s and 4 5s. For 6, I have 5 of those. For 7, I have 6 of those, so that would be 6 out of 36. And then it starts decreasing again. So for 8, then I only have 5 of those. Then 4, 3, 2, and 1.
Wait, I just don't get how
Now,
do you
because
change
this
it
is a
from
probability model, then I should be able to add these up to get 1. Sorry, what was
And
that?
Sorry, I was cutting you, but I just don't get how did you change it to from dates like to numbers?
So all I did was just highlight these, and I changed the number formatting from general, where it automatically turns it into dates, to be number.
Okay, thank you.
So that was all I really did. I can also put them as fractions, but some of those are too small.
Thank you.
Yep, no problem. But if you do want to check that this is a probability model, then you can take the sum of all these and you should get 1.
Okay, so Linda, what is the, and again, using the rules that we had, what is the probability, and a person wins if they, I mean, there's other ways they can win, but they will win if you hand them the dice and they roll the pair of dice. Let's see, do I say pair of dice or pair of die? Anyway, I'm not going to try to figure that out. But anyway, if they roll the 2, of them and they'll get a 7 or 11 on the first go round, they will win. What's the probability they win on the first roll?
So that would be the combined probability of a 7 or an 11. So all I'm doing is just adding up those respective probabilities. So that would be 0.22.
Okay, and craps is an interesting game. The house always wins, and you all should know that. But craps is a game where you have a little better chance of winning than a lot of the games in casinos. So anyway, that's a comment there. Okay, so we talked about a sample space, and we talked about a probability model and adding up to 1, and so we covered a lot of ground with this, so that's good. Linda, let's go back to the slideshow if we may, please.
Okay.
Okay, so we talked about a sample space. So I'm going to advance the slide. So we went through and we did something. But now we're going to start talking about the rules of probability. And Linda already actually referred to some of these already. But by the way, the probability is a function, and you should think about that. So you see, and Linda's been using the correct terminology, but up here, this is, it says P of E. That's just like F of X. But instead of putting F of X in there, we're putting an event. But the probability is a function. So the domain is you're putting an event in there. So the probability of any event E, P of E, must be greater than or equal to 0. It can be equal to 0 if it is an impossible event. And it is always less than or equal to 1. And it can be equal to 1 if it is a certain thing, okay? And let's see. So Linda, can you tell me something that you think is a probability of 0? Some event.
I would say this class ending early.
Okay, and that was funny, and that was good. So that is good. Some people say the only certainties, which is the probability of 1, is death and taxes. And that's, a little bit of a joke too, except it's not really funny, and it's sadly it is true. Okay, but then we go to number 2. The sum of the probabilities of all outcomes must equal 1. And that means is if your sample space was E1, E2, E3, if I say the probability of E1 plus probability of E2 plus probability of the last event has to equal 1. And so, and Linda showed you that, the little model that she did was good. And we call that a probability model because a probability model of possible lists the possible outcomes and the probabilities. And it's a probability model. It must satisfy those two things. So it has to be non-negative. It has to be a number between 0 and 1. No negatives, no 5s. It's all fractions. Or it doesn't have to be fractions, could be decimals, but it's numbers between 0 and 1. And if you add up all the probabilities, it must be 1. Now, there are some problems that are in the book that are called, let's see, what are they called? Oh, they will give you something. They'll say, is it a probability model or not? Okay. And this thing over here, if you look at this, this is the color of M&Ms. And by the way, M&M company, that's the Mars candy company, they actually care about the distribution of colors. So all colors are not the same. And this is a probability of distribution of what they want. And I think that does add up to 1. In fact, that's what this example is saying. It does add up to 1. We talked about a certain event being probability 1, an impossible event being 0. And Linda, the more I think about it, the more funny that your joke was. I actually like that. Okay, we keep going. Now we talk about what does it mean, and often in a problem they will ask, is an event unusual? And you might say, well, what's unusual? Isn't that in the eyes of the beholder? And it really is. But I'll tell you what a statistician means. An unusual event is an event that has a low probability of occurring. And you might say, yeah, but what's low? Well, here is what we usually mean when we say it has a low probability. An event with probability less than 5% is considered unusual. Okay. Now, that's a very, very conservative approach to life. I every day take risks that are way more riskier than that, and most people do. But this cutoff point isn't set in stone. But if the problem just out of the clear blue sky says, is something unusual? Then you say, well, the probability of happening is less than 5%. Then you'll answer that. And if we think back to the empirical rule for bell-shaped curves, that would suggest that an event is not unusual, which means it's usual if it's within 2 standard deviations of the mean. Because you remember, 95% of the data points of a bell-shaped curve are within 2 standard deviations of the mean. So that means 5% are outside of that, and that's the reason there's kind of a double negative. I don't know if I like the way I said that, but Linda, can you improve on that, or do you think it was okay? It wasn't wrong, it just sounded clumsy rolling off my tongue.
I think it's all right.
Okay, good. That means she's thinking about, she has only 3 more minutes left. So anyway, and Linda, I'm teasing. I think you were sincere. Okay, and look what happens here. So if you're approximating probabilities using the empirical approach, that means you're running a little experiment. And that's what Linda did. She ran a little experiment, didn't she? Not with the dice. she did an experiment with the goat game. And so the probability of E is approximately equal to the relative frequency with which E happened. So you see, Linda said, how many times did I win by switching over the total number of trials? So you see, this is approximation probabilities using the empirical approach, and that is what we did in the simulation. Okay, now Linda, I don't think there's, well, I don't know. There might be time for you to do this one, but this will be your swan song. Okay, this is a frequency chart. And, Linda, I'm not going to make you do that. I don't want you to be late. Okay, so Linda's not going to be late, so I'm going to talk about this. So, Linda, just shove off whenever you need to. And thank you for everything you did tonight and for everything you do every day. Okay?
All right.
Okay, so we're going to talk about this in just a moment. And I'm going to build a spreadsheet of this. And I am so, well, okay, so I'm going to take these numbers. And Amber, are you still out there?
Yes.
Okay, so Amber, I'm deputizing you a little bit like Linda. Okay, now here's the only thing I want you to do. I want you to write these things down so you can tell me these numbers, because I'm not going to remember all these numbers. Okay, so just like, I'm not going to say memorize this chart because I think you can look at the chart, without me, but I'm going to be going to Excel because we're going to talk about this. But you see, this is a frequency table. So what somebody did is they created a survey, and Amber, you can decline to do it, but I think you're up to this task, and I'll make sure you understand what I'm asking you to do.
Yeah,
But
I got.
somebody did a survey, and they said, hey, how do you, and this me how do you, and probably they were asking like, how do you get to work? Okay. And so, and they gave you choices. It was a multiple choice thing. So they said, oh, well, do you drive alone in a car? Do you carpool? Do you take public transportation like a train or something? Do you walk to work? One of my dreams actually is I would love to just be able to walk to the college at a page. And I do that, every day and joyfully do that every day. But I would love to do that. But most people don't live that close to work. I live close, but not that close where walking is a thing. Now there's other means, and other means would be, well, something else other than these things. But it could be a bicycle or something like that. And then some people say, I don't travel, I work at home. And so we have that. And now, so what they did is they asked all those questions, and then they summarized the result. But this summary is a frequency, not a probability. And so what we're talking about here is changing a frequency result into a probability result. And so again, Amber, what I'm going to ask you to do is, and I'm going to put means of travel and I'm going to put frequency there, and you're just going to tell me drive alone and 153, stuff like that. Are you good with me, Amber?
Yeah.
All right, great. Now I'm going to lose this, and that's why I need Amber or someone to do this. So I am doing, let's see, what I'm trying to do is end show. Oh, damn it. Did Linda put this up? Can I, Can I, she was sharing her screen. Let me think about, oh, I'm going to try to share my screen. Hold on. I think I know how to do this. Okay, so I'm going to share my screen, and I'm sharing my application screen, and it will be here. So I'm sharing that. But that means what I can do is, now I lost that. Okay, so that's good because I really want Excel. So I'm going to be throwing up an Excel spreadsheet that should be having nothing on it. And so here it comes. It's Microsoft 365. It takes a long time to do all of this stuff, but it is coming. Look how slow that's logging. And then I got all kinds of additional stuff on my Excel, so it bogs down a bit. Okay, so I'm here. And Amber, you can see I'm making progress, right? You can see the progress?
Yes.
Okay, so now I'm typing means of travel here. We're just really recreating this, but now we're going to do something with it. So that is means of travel. And I'm going to, let's see, I'm going to make this a little bit bigger because it's not a huge table. So I get that. It's means of travel. I'm going to adjust this so it fits better. And then this was called frequency. Okay, and we go down here. And so what was the first one, Amber, please?
It was driving alone.
Driving alone. Okay. And the frequency, I think, was 153. Was that right?
Yes.
Okay, thank you. So that's 153, and that's the only, well, I actually remember some of these other numbers. I'm actually pretty good with numbers, but anyway, what's the next one, please, Amber?
It's carpool,
Okay, and
and that was 22.
thank you. Okay, so that is good to go. And next, Amber, please.
Public transportation is 10.
Thank you. And again, I'm anal. You don't have to do this, but I like doing that. Okay, she said it was 10, so I will find 10 on my number pad, and that is good. And next is,
Walk with 5.
okay, great. And so I will type 5 here, and that will be good. Keep going.
Other with 3.
Okay, so we have other is 3.
And work from home 7.
Okay, thank you. So this is work from home. And that was 7. So that's how the way the survey happened. And by the way, this is how surveys are going to work. I mean, you know, if you were doing a political thing, like in California, they just did an election yesterday, and it was, do you want to recall the governor, or do you want to let the governor keep his job? And so people voted on that. Now that would, and actually that was that, and you might say, well, that wasn't a big multiple choice. Actually, it was, because there were 44 other people who were wanting to be governor, and it's a very complicated ballot. But anyway, that's the way surveys work. Okay, so we have surveys here. That's the whole thing. Now, the thing that I would be asking you to do, and you know, this would be useful, and you can say, well, what does all this mean? But now what we're going to do is we're going to use this empirical data to come up with a probability distribution, okay? And the event here is, what's the probability that someone drives alone? What's the probability they are in a carpool? What's the probability that they take public transportation? What's the probability that they walk? What's the probability they do something else? And what's the probability that they work from home? So this is how you do this, and this is actually the formula that I was showing you before. Okay, so what I'm going to do then is I'm going to add these things up. So I'm just going to say sum. And okay, so this is, and I'm a little bit in the dark here, and that's making me type the wrong things. Okay, so this is going to be the sum of all these things. And then I'm going to have to put a parentheses on there, a closing parentheses. And okay, I think it's this one. It is. Okay, so I add that up. And this tells you how many people you interviewed in the survey. So you interviewed 200 people in the survey. But now we're going to change that to probabilities. So you see, this really is the event, which is X. Okay, so that's the event. You drive alone, or you're in a carpool or something like that. But now we're going to calculate P of X. Now we needed that frequency there, so this is P of X. Come on, Jim. That's P of X, so I want to put an X in the middle of that. Okay, and so I will just put an X there. Okay, so that is good. And I will center that just because I'm anal about that sort of thing. Okay, so this is P of X. Now what I'm going to do is I'm going to divide the frequency by 200. But I need to be a little bit careful because I want to divide by the frequency. And by the way, everybody, I'm making a mistake on purpose. Okay? I know what I'm doing, but I'm making a mistake to make a point. So here I'm going to say, okay, so this is then equal to, I really should turn a light on in here so I can see. So that is equal to, I guessed right, that was good. So I'm going to say this is that number, and then I'm going to divide by this number. And by the way, that was a correct calculation. But then you might say, okay, and then Linda always just drags it down. And look what happened there. And you might say, WTF. Well, what happened was I didn't, you see, when I'm pulling that down, that moves to this one, but it also moves to this one down here. So it thinks I'm dividing by 0. So that was not a good thing to do. I made that mistake on purpose. And what I really need to do is make, and I know we've talked about this before, I need to make this cell B9 an absolute reference so this one doesn't move. It's always going to be 200. Okay, so I'm going to do that by making this a $sign, which is the shift on the 4. And then I have to do the $sign here on the 9 too. And y'all remember we did that before, but here we are doing it again. So now I get that. And now I can pull that formula down because it's always going to be looking at B9, and I get that. Okay, so we get those probabilities, and as Linda said, that should add up, and I'm just going to pull the formula over. And you see that does add up to 1. So you see what we have discussed then is how do you change a frequency distribution into a probability distribution. I'm going to pause, count to 5 Mississippi, and see if there's any questions about what I did, because I expect you all to be able to do this. And I don't know if people are asking questions or not because I'm hearing beeping in the background, so I don't know. Are people, okay, someone asked about the formula, and Layla has her hand up. So I guess I'm going to, I will show you the formulas in just a minute. Layla, what is your question?
Can you please do it again? Like when you did it a mistake and then you did it, you fixed it?
Yeah, I was actually doing the mistake because I thought that would explain something to you, but maybe, all right, I'm going to show the formulas first, okay? Now, you always can show the formulas, and you click on formulas, and then you say show formulas, so we will see formulas there. So those are the formulas that I did, okay? Now, what happened here then, I'm going to try to answer both questions. So here are the formulas that we had. So down here, you see, I added up all the frequencies. So that's how many people I surveyed. That's how many people responded to my survey, okay? And that now that is a number, but this is the formula, okay? That's what I typed in, and then I drug the B2 through B7. And then the formula over here, and Layla, I'm talking to you, and the only reason we're talking to you is because of the question that you asked. The thing I screwed up here, and I did it on purpose. A lot of times I make mistakes and it's not on purpose, but this one actually was on purpose because I wanted to show you what happens. Okay, so I took this B2 and then I did B9 where I clicked here. Now that didn't cause a problem here, but when I pulled that down, then it was B3 over, and that would be B10, which is not where the 200 was sitting. So I had to use absolute addressing here. So this is B2 over, that's the $sign business. And you notice now when I pull it down, I get the $sign business, so I'm good. And then the last formula that I was doing is down here, that was called the sum of, and this was, you know, adding up the probabilities. I just was demonstrating that that did indeed add to 1. And so we're good about that. Now someone asked a question. Well, it's Amber, and so Amber, yeah, tell me what's on your mind. And Amber, while I'm waiting for you to say something, I'm going to stop showing the formula. So I'm going back to my numbers. Okay, go ahead, Amber.
I was just wondering if, like for the midterm, should we always be checking if it adds up to 1?
if you're working a problem about that, that's a good thing to do. Yeah.
Okay.
Because if it doesn't add up to 1, something's rotten in Denmark. And you might say, oh, Jim wrote a bad question, and that probably happens sometimes. But Linda looks over the questions I have, and sometimes she said, Jim, that's a bad question. Why don't you ask some different question? And so we can do that. But yeah, that's a nice check. And boy, it's pretty easy to do with Excel, isn't it? And by the way, you might say, well, yeah, but I'm just not going to worry about Excel. I think you really want to be not worrying about Excel, but you want to be using Excel, because when we get to the midterm, you really want to be using Excel, because these calculations could get way involved not using Excel. Okay, so you're still sharing my screen, so I'm losing Excel because I don't want it anymore. I'm not even going to save that or anything else. And do I want to save those? No, that's copies of bears. No, I'm just going to remove all those. I don't need any of those. So this is going away. I don't know what that's all about. Oh, it's recycling the things. I really didn't want it to do that. Okay, anyway, it's done. Now I'm back here. Now I do know what time it is. I always know what time it is. And someone might be, oh, I think that's probably people leaving. I'm going to dismiss you in a bit. We talked about probability models. I guess we didn't need that. And we're moving on here to, we talked about unusual events. And then we talked about that too. And we talked about this. That's the problem we just did. Okay, now there's another way to do this. And the other way is for you to use a classical method. And notice that Linda didn't do any experiments with those dice to write that, did she? She just said the probability of getting a 7 is, how many ways can you get a 7 divided by the total number of things. So there were 6 ways to get a 7, and the number of possible outcomes was 36. So the probability of getting a 7 is 1 time out of 6. Now, we can talk about other things like having a boy and girl, and this is where I guess we're going to press the pause button, and we'll pick this up later, whenever we get together again, because it is 7:15. And Linda said this, she said it was a probability 1. This class would not end early, and it didn't end early. So I guess Linda is right again. You all be careful and take care. Time is precious. Each day must count. Do the math. It will make you strong. And now I need to call Nicole and look up Layla's emails or something. Okay, so good night and be safe. Good night, Jasmine.
Am I good to go, or you want to check it up?
You're good to go. You're good to go.
Okay, thank you. This is Layla. If you didn't receive
Oh, you know
anything,
what I should have done? I should have stopped that recording. I screwed up. Well, anyway. Well, wait, you're still there, so maybe I can go back and stop the recording too. I'm not sure where it even is now. Okay, so I can still talk with you. What I'm going to do is I am going to find your email and start working on your accommodations, okay? So I'm sure it's there, okay? Layla, are you there? Okay, all right. Okay, so that's it. Hey, Nicole. Yeah, I mean, I don't know. I think you have. I mean, I think the technical issues probably were on your end, but if you want to just set up a Zoom where we can, try our things again. I'm trying to remember when we did that, or let me just ask you a different way. Now, I've got my own schedule, and of course, you have your own schedule. I know you're busy, and things like that. So when could we talk again, or when should we talk again, so that we can address? So I'm asking, kind of, when are you available to talk? Yes, you can. Yes, you can. Now I'm trying to remember. You told me where you lived, but I don't remember. You didn't say what? Did you say West Chicago? Elgin. Okay. Well, that's a little bit of a hike, but I would be happy to meet with you. You know, and that's early, and I don't know if this works with your work schedule because I know you work a lot too. But I am in there. This weekend it turns out Friday I'm going to be in there from 8 to 9. This coming Saturday, I this coming Saturday, I think I have to have a it's just a cleaning, but I made it a dentist appointment, so I'm going to do that at 10. So that kind of gets in the way of that. Uh, but uh, but and by the way, I mean, we could try to do the Zoom thing. I mean, I could set up a one Zoom thing, and if it and by the way, if it doesn't work, you can call me and at least we can talk, okay? And I'll tell you another thing we can do if you wanted to, whenever we get around that. We don't have to use Zoom. We could use Blackboard Collaborate because that's just sitting there, and apparently that was working for you. Okay, so we could do that too. So that's there. So and so again, what I'm going to ask you, Nicole, is what's a good time for uh, well, you were talking about Friday, weren't you? Or no, you said Friday didn't work. So, okay, so what's a time when might work for you, and we'll see if it works for me. So throw something out there, please, Nicole. Thursday evening, it has to be late because I teach late into the evening on Thursday. I'm teaching till actually I'm tied up at college until and Thursday's tomorrow, isn't it? Well, I'm tied up until 10 o'clock at the college. So, that's getting to be late. Um, yes, I do. Don't be embarrassed, okay? Well, don't, no, I'm asking you not to be, okay? Well, now, yes, yes, it does, and there's no need to be embarrassed about that. And word problems are hard, but I'm also going to tell you that world life is a word problem. I say that often, but it's really true. I mean, like I worked as a mathematician in industry for almost 20 years. And I never had a boss, man or woman, come to me and say, Jim, solve this equation. It never was that. It was, oh, gee, there's some horrible thing happening. Go see if you can help these people. And, we go over and we work on the project together. So it is a word problem, okay? That life is a word problem. So it's a good skill to have, but it is not an easy skill. and you got to read the problems carefully and all that. And you and I can talk about that, and we will talk about that, okay? But it's not easy, and it requires practice. And by the way, almost anything worthwhile in life, and I think you are experienced enough to know that almost anything in life that is worthwhile does take a lot of work. So yeah, so we'll get there. Okay, so I'm trying to remember where now you're saying Monday. Okay. Well, okay, so Monday can be good. Now, one thing I want to tell you is there is a student that I'm working with in a different class, not yours, who we check in on Monday. But I'm going to suggest that could we do this at 8:30? Okay, and now 8:30, and we'll try it on Collaborate, Blackboard Collaborate in our classroom, just like what you've been doing. Okay. And we'll try that at 8:30, okay? Okay, well, you take care of yourself, and I think you're worth it. So that's all good, okay? All right, bye-bye. Oh shit, I'm so tired. I just want to go home and be with. like to be with Pat's pussy's what I'd like to eat. I'm in California dreaming of used to be. God, she's pretty. I'd like to. God, she's. I pass along the way. I like the concept of Desperado. It's a good song. He's a pretty guy. I love teaching math. I wish I could teach some math more. Also,